Okay, lesson 1-3. Today we're solving with variables on both sides. Key idea here is you got a variable on one side and the other, and you're going to try to get them together. Okay. A couple of reminders here before we get going. Number one, you're going to encounter ratios and fractions, and one thing that we'd rather not work with is these things. So to cancel them, multiplying is a way of eliminating the denominator. So since my denominator is 7, if I multiply this ratio by 7 over 1, we would get 21 over 7, which is just 3. So notice how that numerator gets isolated from the denominator by multiplying by 7 over 1. Okay, so that's just a little tip to keep in mind. Number 2, reminder number 2 is get rid of the parentheses first, always in a problem, and then collect like terms. So here we go. Strategies for today. When you want to get variables on the same side, you're going to have to cancel one of those variables by adding typically the opposite to cancel it. Okay, so get variables on the same side by using what we call the addition property of equality. And finally, that little tip there. Sometimes you'll want to cancel denominators by multiplying okay? So two little strategies as we work through the problems. First problem here, example 1, solve and check. So we've got two variables. We see an x here and an x here. And we want to get these on the same side. So we're going to cancel one of them. Now you can choose to cancel either one. In this case, if you want to avoid negatives, cancel the larger negative. So I'm going to add 9x to both sides. And what that does is this side becomes 0. I'm left with a negative 5 here. And I have negative 4x plus 9x gives us 5x. We still have the 10. Okay, it has now become plus 5x though. Next we want to move the 10 to that side, so I'm going to add negative 10 to that side and get 5x equals negative 15. Our last step, divide both sides by 5 and we get x equals negative 3. I'm going to check to see if that answer worked, going back to our original problem. Plugging it in. So we have 10 minus 4 times negative 3 and negative 9 times negative 3 minus 5. So 10 plus 12. Notice how I changed that 4 to a negative 4 so that I could multiply those two negatives and it becomes positive. Negative times negative 3 is 27. And this side here is 22. And this side here is 22. So it works. All right. Again, key here, the new idea, cancel a variable on one side to move it, in essence, to the other side. Example 2. We're going to solve and check. Here we've got some parentheses, we've got some ratios. So again, the first thing we'll want to do is distribute. And distribution gets rid of those parentheses so we can start moving things around. The temptation might be to dive in and like add 4 or subtract 56 from both sides, but you don't want to do that with those parentheses there. 3 times 3, 9x. Again, I'm going to think about that as a negative 4. So 3 times negative 4, 12. slap the negative on. Now, 1/4 times 32. So over here on my paper, I'm going to write 1/4 times 32. I'm going to write 32 as a ratio so I can see that. Now multiply them across and we get 32 over 4, which is 8. I'm going to tack on the x. So this times that gives me 8x. And using the same strategy, I'm going to take 1/4 times 56. And we get 56 over 4. And 4 goes into 56, I think 16 times. All right. Well, we have an x here. On this side, we have an x on this side. To get them together, I am going to, they're both positive. So in this case, I like positive numbers, so I'm going to cancel the smaller positive number by adding negative 8x to both sides. So this 8x and this 8x becomes 0, and I'm left with 16. And then over here I have a 1x plus a negative 12. All right, add 12 to both sides, and we get a 1x equals a 28. Now I'm going to go back and plug that in to make sure that it works. Draw a little line here to show that I'm doing my check on this side. 3 times 3 times 28 minus 4 should equal 1/4. 32 times 28 plus 56. Probably going to need a calculator at this point. Hopefully you've got one handy. 3 times 28, we're going to work inside the parentheses there. So clear that. 3 times 28, 84. So 3 times 84 minus 4, well, that's going to be 3 times 80, which is 240, I think. Yeah. Now I'm going to take 32 times 28 and add 56 to that. And I get 1/4 times 952. So I'm going to divide, in essence, 952 by a full 4. And we get 238. So close. I must have made a mistake somewhere. Let me double check. 3 times 28. 84. 84 minus 4 is 80. Yep, that checks out. 32 times 28. Plus 56. Divided by 4. 238. Huh. Well, clearly there is a problem here, and I am not seeing my mistake. 240 does not equal 238. I found my mistake. Good thing I checked my answer. Back up here, when I took 1/4 times 56, 56 over 4, it isn't 16, it's actually 14. So this here is an incorrect value. So that should have been 14. So it's actually 14 plus 28 plus 12 is 26. So my answer is 26, not 28. And now, sure enough, when I check it with 26, it does work out. We get 3 times 26 minus 4 times 3. We get 222. and 32 times 26 plus 56 divided by 4. This side we get also 222. All right, phew, good thing we checked. Last problem. Sometimes you're going to solve a problem and something strange is going to occur. In this case, solve and find the number of solutions. Now that's kind of a weird question because every time we've solved, we typically get one right solution on all the examples that we've done so far. Well, sometimes you're actually not going to get an answer, or you're going to get many answers. Later on in algebra, you're going to solve something and maybe get 2 answers. So here we go. Following our procedures of getting rid of parentheses, we get negative 8y. Negative 2 times 1 is negative 2. So now I'm going to get my y's together, and I'm going to add 8y. And I notice now that something strange happens in this problem. Not unlike the last problem, but notice my variables completely disappeared. The 8y's went to 0. And I'm left with negative 2 equals negative 2. Now this is a true statement because negative 2 does equal true. So we draw 3 little dots like that, and we say there are an infinite number of solutions. Okay, or you can just write infinite solutions. But it doesn't really matter what you plug in for y here. You could plug 0 in, you could plug in 10 or negative 52 million, and you would still get it to be the same on both sides. Okay? All right, good luck in your homework.